So why don't we use green? Right, green. Green's a good color. What's the cotangent? It's -1. It's not negative. It's not pi over 4. It's pi over 2. Negative pi over 2. What's tan inverse arctan of -1? How did you get that? How'd you get this one though? That's weird. This is supposed to be correct. Oops. It's 2.3, right? 2.3. Let's see this guy. This one right here. Let's see. Cosine 2 pi over 3 is 1. What's cosine 2 pi over 3? Cosine 3 is -1/2. And what's arc sine of -1/2? Negative pi over 6. I don't know why you got this one wrong. Sine of what's the arc cosine of 1/2? Pi over 3, right? Which is 6 pi over 3. What's the arc tan of square root of 3 over 3? Pi over 6. So that's going to be, let me see, that's going to be 2 times 2, 2 pi over 6, 2 pi over 6. So that's pi over 2. Sine of pi over 2 is 1. Just 1. This one right here would be, let's see, this one is, what's the arc sine of -2/3? Arc sine of -2/3. And then you put secant. It's this guy. It's actually this guy. How'd you get that one? So first of all, How do you do the arc sine? What gives you 2 and 3? Doesn't nothing gives you 2 and 3, right? Inverse sine. How the heck do you get this? Sine of negative 2/3. Is that what they did? They did the square root. Like what we did with the other one, right? So when you get 1 plus 10 squared, yeah, sine squared. How do you get cosine squared out of 1 plus 10 squared? How'd you get, let's see. We'll cover this one, sine x, cosine x. What is this? Sine x divided by 1 minus sine theta 2 times secant x. 2 times secant. What are you supposed to do with this one? Plus cosine 1 minus sine. Hello? Can you hear me? Hello? You have your mic on? Hello?
Hello.
Hey, how you doing?
I'm
Can you hear me?
Oh, my bad. I'm good. How are you?
Pretty good. Yeah, sorry for that. I got your stuff, so your notes from your professor or your teacher.
Yeah, she said that she would send them to you, so.
Okay. So like, yeah, like there was a few things. I think it's not that bad, but because you have another exam coming up, and it's gonna be kind of similar to this.
Yeah, I know what I did wrong. I just I
Oh,
didn't show
okay.
it the way that she wanted to show it.
Yeah, it's kind of weird. Why? So like, I guess I wanted to ask you, like, does she want? Do you see my screen by chance?
Yeah.
Okay. Does she want the answer to be because like she marked this wrong right here, but then does she want it to be in this form?
No.
Or what? Because it looks like this is this supposed to be an inverse? Or what is this?
I thought it would just be the inverse.
Okay.
I'm actually like kind of confused on why I got that wrong. But okay, so yeah,
like,
it would be cosine of -1/2, right?
yeah, this one right here should be an inverse. But yeah, it should be cosine inverse of -1/2. Or if you solve this guy, like so like remember we talked about like like establishing the triangle? Or
Yeah.
it's always, I think it's good because you've been doing it using like memorizing the unit circle, right?
Yeah.
And like what the thing is with that is like it's really difficult to, you know, like what if the problem doesn't match or you forget what the actual value is like in the unit circle. But maybe we can
No,
I guess
yeah, I get why. Never mind. I get why I did that one wrong. I just didn't do negative. I had it positive, so that's why.
for which one?
For that one, for number 10.
Okay, and then so that's how you got this guy.
Yeah, I just I just forgot about the negative sign.
Okay, that makes sense. So okay, yeah, you could Yeah, like look out for those, especially for the
Yeah.
signs. Like kind of like just check. Okay, so this one you get. This one. What about this one? Because I was trying to look at this,
Hmm.
and if you do the tan inverse of -1, like arctan of -1,
Yeah.
I got the same answer as you. It's -pi/4, right?
Yeah.
Did you ask her about this one? Because I was trying to like, kind of get the same answer and see if I match what your teacher shows, but I don't know if this is supposed to be wrong. It seems like this is right.
I don't know.
Because like if you look at, like if you look at this tan inverse -1, which is the same thing as this one,
Hmm.
it would just go like this. Yeah, it would go like this guy.
Yeah, so it would be -1. That's why I was like, I was confused about that one, but I didn't ask her. I can probably ask her Wednesday.
Okay, make sure this one, because I'm pretty sure this one's correct. I don't know why
Okay.
she marked you wrong with this one. Okay, so for this guy,
Oh yeah.
what about this one? Do you got
I
this one?
thought cosine was just she said that. Oh
Okay.
wait, so that would go from -1 to 1. I just thought it was pi/2 to pi/2. Okay,
Um,
never mind. So
it's
I
this guy,
understand why
yeah.
that's. Yeah, I understand why it's -pi/2.
Okay, yeah, okay. Yeah, just try to go back. Did you have enough time, or was it like super fast?
It was kind of fast.
Okay. Yeah, a lot of these are, because I think for the next exam, you guys' next exam I found out is on the 20th.
Mhm.
And it's gonna be the other track identities. So like maybe you'll see this again, or like, something similar to this guy. But
Yeah.
try to like practice them as much as you can so that like they become very natural. So that like,
Mhm.
yeah. Okay, so you get this one, right? Number 12?
Yes.
Okay. What about this guy?
Is it just supposed to be -pi/6
Yeah.
instead of pi/6?
It's just this negative sign,
Pain. Oh my gosh.
yeah. Yeah, like I said, these negative signs. I mean, how does she grade these? I mean, you got the right value, but you got, and obviously it's no negative sign, so it's wrong. Is it
She
fully?
she just yeah.
Man, that's harsh. I
Yeah.
would give it like partial credit. I mean, at least you did something. That's not good. Okay. Same with this guy. Same with this guy. You had this negative sign, but there's supposed to be no negative sign.
Mhm.
So yeah, I think from what I've seen here, this guy, and then this guy, and then this guy. Like for these three, a lot of it is just knowing, where these negative signs should be, or when they shouldn't happen.
Yeah.
And a lot, I think what it is, what actually, so knowing what it is now, I guess it doesn't make sense, or what was it like? What's the reasoning? I guess that you think you were struggling on the negative
I
side.
think I just made like simple mistakes,
Okay,
which
was
is
it because
really
like time, just the
depressing.
time?
Yeah, I was just kind of stressed. I was like,
Okay.
oh my gosh. I get test anxiety pretty easy.
Was it your only test of the day, or did you have another exam?
I had multiple exams of that day.
Okay. What about maybe that's why? Do you always have that? Is that always the case? You always
That's
have.
not always the case.
Okay. Are you guys able to? Yeah, a lot of people they have that too. Like, are you guys able to move exams or no? Like, so like you can partition it during the week, you know. So like maybe you can have
Oh
one exam during like one day and then the other one, or
no,
there's no
but
excuse. You just have to do it.
no,
Okay.
you just have to do
Okay.
it.
Okay. I guess you just have to practice. I mean, like a lot of
Yeah.
times, yeah, I had that before too. It's just the more you practice it, and just kind of like after you do each of these problems, right? Like
Hmm.
like when you're rushing, you're doing problem by problem, and you're just shooting from like 13, 14, all of that, right?
Yeah.
Try to like when you do this and you did the calculation here, try to at least give yourself like 10 seconds to look back.
Hmm.
Oh, like don't always assume like okay, I'm gonna move on now. It's done.
Yeah.
10 seconds, at least 10 seconds, because that always helps. And it's like a routine where like, okay, like did I make this count error or whatnot? Yeah, for all of them. I'm pretty sure if you do that, yeah, you won't make these negative sign misplacements. Okay.
Hmm.
This one, these are one of the more complicated ones. Like
Yeah, that one
I
was
really
really
I really don't like doing these ones. And honestly, the answer was kind of similar, but it's this guy.
hmm
So it's like this guy right here.
I'm not gonna lie, I was completely confused on that. I was like, what am I what?
Okay. So for these ones, I think it's kind of similar to, remember that one number 20 or that last problem in the quiz
Yeah.
where you have to do some algebra to get this guy,
Mm-hmm.
and then from a trigonometric algebra combination, then you get like like a form here that looks like this, and then you do a secant. I was trying to find like myself in how to do this, but let me see if I can try to find the answer. So it's this guy, and it's not a common like leg 2/3. And let's see. So if you do this, this is just going to be negative sine inverse of 2/3. Let's see. We can find the same answer. How did you get the root 5/3?
I don't know.
Okay, was that just like a choice? Like a guess?
Yeah, it was just like a choice. It was a guess because I was like, okay, I have to put something, whatever.
You were super close. You were super
3.
close though.
I know.
You know, like when you
Which
make us
low-key makes it
like it was
worse.
like right next to it. It's crazy. Let me think. Cosine. This answer, this root 5/3, is if this was a cosine. So if it's a secant, it has to be this guy. But
So
let me see if I can figure it out.
because I was trying to do a squared plus b squared equals c squared, but that wasn't like 1, 2, 3 isn't a triangle or anything. So I was like, what?
Yeah, these are one of the more complicated ones. Like, did she show you guys how to do? This is the second time I've seen this, like in your guys' quiz. It seems like she likes doing this ones. Did she ever show you guys how to do that last problem in the quiz, the one that we talked about, where you have to do some algebra? Let me see. So the way I've seen this is kind of weird, but you're supposed to draw a triangle in the plane. So let's see. You have a 0, 0 here. Let's try and make sense of what this means. You have another point. Do you guys ever go over like your exams in class? I think this is like one of those questions where you may have to like know how she does it, and then like ask her, like, is there like a particular procedure to do this problem? Because it's like one of those things. There's like a couple ways.
I think we go over it. We might go over it like sometime next week because some people still have to take the exam, I guess.
Okay.
Because she like wouldn't really let us she let us look at it today, but she wouldn't like really let us look at it. Like we had to we looked at it for like 3 minutes and then she was like, okay, I have to get it back. And then we were like,
I see. Okay.
Yeah.
Yeah, but like this is the 15 is the one I would ask, like step by step. What is a step procedure that I can follow? Because it's the same as the other quiz one. Like ask her about that, and maybe if hopefully this is the last time you'll see it.
Yeah.
I don't usually see these problems. This one, it's usually just the previous ones are common, but this one is like one of the harder, more challenging ones. So
and then the other page, I was so mad because on the verifying ones, I literally just didn't show it the way she wanted me to, and I was so mad. Oh my gosh. Yes, then she took off like.
Oh, you mean the first page or?
No, the other page. It was like the last page.
This guy?
Yes. I was so mad.
This one, okay. So like this one, I wanted to ask. So is this just to prove if they're equal?
Yeah.
Okay, so it's just a proof. Okay. What is your answer here?
it was equal. Like, I found out that it was equal, but you have to show up in a step-by-step, but I showed it, like, I skipped some steps because I thought it was, like, self-explanatory, but she's like, no, you have to do it. And then on the other one, the 23, I didn't show that I factored out the 2.
Oh, right here,
because
okay.
I just did it in my head, and she was like, no. And then she took off,
she said
she
no
said 4 there, but she took off 6 points. Or,
4,
6 points.
It's just 4. Okay, but like for those ones, I guess like yeah, it seems like she wants you to show every step. So just show. Don't do any mental math.
Yeah.
For that, that's so not good. I mean, like it's you obviously got the right answer, and it's only a mental math procedure.
No, it's literally only because I didn't factor. I didn't show that
1 minus sine. Yeah, to this guy, right?
Yeah. And it says that she took off 4, but she took off 6
this guy
on the test.
And yeah, there you go. I mean, I guess Josh, you can't really ask. I saw this twice. This is the second time I've seen this actually. She doesn't want you guys doing this kind of stuff right here.
Yeah.
Because like it's a fraction, yeah. So it needs to be something that's mathematically right. I guess that's the reason why she doesn't want you guys to just cancel it that way.
Yeah.
I don't know. Yeah, but like yeah, I mean that's lesson learned. Just make sure you show all your mental math.
Yeah.
Okay, let me see. Going back to this. So yeah, 0, 0 here. And then how would you figure this out otherwise? So you have another point, 1 squared minus 2/3 over 2/3 squared, okay? And then the other point would be up here. It's literally impossible. I don't know how you would figure this out. 1 squared minus 2/3 squared, and it's 2/3. And then arc sine negative is the angle between okay. Yeah, this one's a hard one. So after you get these points, but how would you get 1 squared and 2/3? Oh, I see. So there's 2/3 here. 1 squared minus 2/3. Let me think. So what if 2/3 was your top divided by 1? And sine is opposite hypotenuse. And this one's negative. Okay, this one's negative. The hypotenuse is 1. Okay. So probably going down. So 1 negative 2/3. Okay, I think that's how you do it. So like, because you know that this is opposite of our hypotenuse, so you make this negative 2/3, and the hypotenuse is 1. And you have to solve for this leg thing. So that leg should be 1 squared minus 2/3 squared. Okay. Okay, so 1 squared minus 2/3 squared. Okay, and then sine inverse would be this angle. Okay. And you want to get the secant of that. Secant. The secant of this guy would be secant. Oh, so cosine. It's going to be hypotenuse over adjacent. So it's 1. Oh, okay, that makes sense. I think I get it now. Okay, are you still there?
Yeah.
Okay, so I think I get it now. So you know how just trying to figure this guy out, but like you know how like you have the sine inverse minus 2/3, right? Inside. So like
Yeah.
I guess a way, I mean if it's the correct procedure, I mean it seems like I can figure it out this way. But you know how like you can just make this negative 2/3 into like negative 2/3 over 1, right? You can just do that, right? And then you know that sine is opposite over hypotenuse, right? So this is your opposite leg over hypotenuse. And whatever I just drew here is what you're supposed to do. So you have this negative 2/3 right here. And then this 1 as your hypotenuse. And then you just work with this. And then, obviously you have to figure out this missing leg. You have 2 legs. You have the hypotenuse, you have the opposite leg. You just need to figure out this this adjacent leg with what you have. And then, because you have this picture, you can figure out the secant one now, right? It's just going to be 1 over this leg that I figured out. Square root of 1 squared minus 2/3 squared, right? And then, and then you simplify that. So like this whole thing would be 1 over the square root of 1 squared minus 2/3 squared. And if you do like all the procedures there, you should get a value that's close to what we have here. That guy. Does that make sense? It's like, I think you could do this algebraically, but I feel like you have to draw a triangle. Do you know
where did you get the over 5?
Oh, the over 5. So you know how like I think when you do the math here, you're gonna get something like 3 over root 5, and then you just times this by root 5, and then times this by root 5. Did you do the math of this guy? Like I kind of skipped that part.
Oh, okay, yeah, I get it.
You get it? Okay, cool.
Yeah, okay, yeah, I get it.
Yeah, so like that's really, I mean, like there's two procedures. If you find something like the one that you had in the quiz, you have to do like the algebraic way. And then if you find something like this, just draw a triangle from inside out. So draw a triangle from the inside inverse trig. And then using that same triangle, find the actual trig function.
Okay.
Does that make sense?
Yeah, that makes sense.
Okay. Yeah, I think to do these types of problems, you just have to make up like different ones like these. You know, like maybe this is a cosine. What if you change this to a cosine and this is like like a sine, or like sine and cosine inverse 2/3, something like that. You just have to have like a plan of attack. Like, and let it fit. If the algebraic way doesn't work, then use this geometric way. Okay. So those are good. What about 19? You remember what you got, or like what the answer is?
No.
Okay.
It's 1. I think it's 1. Wait.
I got cosecant x, not squared.
Oh.
Okay,
wow.
I guess let's cover it. So you know how you have this guy, right? You have this sine and sine right here. You just have to factor that out because you're gonna see like a trig identity. This guy right here.
Oh.
Right, 1 plus cotangent squared.
Yeah.
Which one is that one?
That equals cosecant.
Yeah, cosecant squared. And then after that, what you have to simplify cosecant squared to its like regular function.
Oh, okay, I get that.
Oh no, not cosecant squared. You have to get the sine in terms of cosecant, and then it cancels out the cosecant. Yeah. But yeah, that's really what it is. It's not that hard. It's just
yeah, I didn't have to do that.
Oh wait, so
Okay.
did you know how to do that, or was that how did you try to get this answer actually? Let me see what you did.
No, because then I realized I did it wrong after I was done, and I was like, oh heck.
Okay, I think let me see. So this is the first step you did, right? Right here.
Mhm.
Let me see. And then you were doing cosine squared over sine squared to try to cancel something out here, right? You were trying to do
Yeah.
cosine squared over sine. Yeah, maybe this could have worked. Um, yeah, like there's really no like hard fast like procedure. It's really just can you make or see a trig identity? It's that
Yeah.
that's the game. Like do some algebra, find a trig identity, simplify it that way. And I think that's the hardest
Yeah.
part about these guys is
I
like
was really just like speeding, so.
yeah, I know. But like if you I would say so you guys are not given the trig identities, you have to memorize it.
No, we actually got them
Oh, you
for the
guys got them.
test.
Okay, that's even easier. Yeah, if you see this, like just if you have it in front of you, just look at the trig identities and see. Okay, how like think for like maybe 10 seconds and look at this. How can I get like
Yeah.
a 1 plus cotangent squared? You can see it right off the bat, right? You can see it. It's like right here. 1 plus
Yeah.
this guy. Yeah, so
Yeah.
I would probably take the easiest route. Don't do anything like super algebraic,
Yeah.
Uh,
Okay.
all right. So and then for this guy.
Yeah, I just didn't know that you couldn't just do it from there.
For this one, what was your final answer? It's like all of this. It's like, well, it's all of this, right?
Yeah.
You were just trying like different things.
Yeah.
Okay. See, like the procedure here is not even that long. It's only 2 step. One.
Leave me alone.
No, but like really, it's what you can like see. Like the trig function is here. The trig identity, like 1 minus cosine squared x. I think you got that part, right? You got this top part.
Mhm.
But then what about the bottom?
It's sine over cosine, right?
Yeah, it's just secant squared. This is like a very common one. 1 plus tan. It's the same. It's kind of similar.
Oh, you mean the identity?
Yeah, 1 plus tan squared x.
Oh, I just like simplified it into sine and cosine.
Yeah, no, I see that you like to do that a lot, like right here as well.
Because that's what she does all the time.
Oh, really?
Yeah, she always tries to simplify into sine and cosine.
Okay, maybe that's her fault. That's the reason why you guys are confused. But like, what I would do with these kind of things, like when it's time to simplify, not to evaluate. When it's time to simplify these like trig functions or expressions rather, um, you don't try to like convert everything to cosine and sines. For like maybe if that's the last step, maybe do that, to simplify everything. But don't make it your first step. What I would do first is to look at your trig identities, and then because most of the time these tan squares and cotangents, they're really there's a lot of identities that's associated with them.
Yeah.
And then it's like these two are like the main ones. The 1 plus cotangent squared equals cosecant squared. 1 plus tan squared equals secant squared. Those are the main ones. They're like the top three. Sine plus cosine squared equals 1. And then there's this guy which is second, and then there's this guy which is third. Like the big three guys.
Yeah.
And you'll definitely need those because I think it's just gonna get harder. The next exam is gonna get harder. You're gonna be doing the other ones, the half angle ones, which is like something I don't like to do.
Oh, we have a formula for it.
Yeah, let me see if I can get that back. It's I got some did you guys get new things this week? I got this thing from your teacher.
Just today.
Okay. Let me see if this is the one. Can you see this?
Wait, yeah, I can see it.
We
did that. We did that in class.
You guys did this in class, okay?
Yeah.
There's another one as well. Let me see if you this. What about this one?
I think that's for we're supposed to do that at home and then turn it in tomorrow.
Okay. Did you start on it already?
No, because you're supposed to like do it tomorrow. Because we don't have school tomorrow. It's like an at-home learning day, and we're supposed to do that tomorrow.
I see. Okay. We might as well cover these because I don't know when you guys are gonna move away from these guys.
Oh yeah, we did that part in class.
Okay. She didn't actually show me the so for this one, what did you guys do? The exact value of cosine. think we're
So
done with
there's
this one, right?
form.
You already like before we move on, you already understand
Yeah.
this guy, right?
Yeah,
And then
I know.
this
Yeah, I
one,
know
you
it.
got
I
this one.
understand what I did wrong. Yeah.
And this one, you got this one. Okay. All right, cool. All right, let's move on. So for this one, yeah, how did you guys do this? Exact value of cosine 15.
So you're supposed to find like values that you can see on the like what minus what could equal 15 like on the chart. So 45 minus 30 degrees.
Okay, let me see.
And then there's a formula. I think it's cosine A minus cosine B equals cosine A
what in the world?
plus A cosine B minus sine A sine B.
Okay, let me turn this to a PDF. I don't like working with these guys. Okay. I'll say so. You split it into known angles, and then
Yes.
like what do you do next? So what did you say? 45, right?
45 minus 30.
Okay. And then what did you guys do after that?
And then there's the formula. So it's the formula I think is cosine A. I think it's
Cosine
cosine A minus cosine B.
Oh, I think I know what you're talking about. Cosine
equals,
A minus cosine A minus cosine B. Let me think if this is. Let me try see if this is cosine. Is this a trig identity or is this something else?
It's like a new. I don't know.
It's a trig identity, right?
I guess, yeah. I don't know. I don't really know the terminology.
It's probably cosine A times cosine B minus sine A times sine B. Is that one? Something like that. Let me look back and see if that's the one.
Well, it's like in the thing, and it's like cosine A minus cosine B equals cosine. Yeah, that. Yes.
Is it this guy right here at the bottom?
It'll be the second one.
Oh, the second one, this guy?
Yeah, because you have to minus the 2 to equal 15.
Ah, I see what you're saying. Okay. It's been a while since I did this.
Mm-hmm.
So, like, let me see. Let me go back to where I was at. Oh, whoops. All right. So this one is, I see, and then you take the cosine of that, and then you split it. And then your A would be your 45 and your B would be 30.
Mm-hmm.
So you just do this.
And then you find like the actual cosine of that and the
and that's how you do the exact value. I see.
Yeah.
Yeah. So like it would be cosine of pi over 2 or pi over 4 rather.
Mm-hmm. So it'd just be square root of 2 right?
And then cosine of 30. So you know how to do this one?
Yeah.
Just applying in a plug and chug really, in essence.
Mm-hmm. Yeah.
Pi over 4. Then sine of pi over 6. This is pi over 6. Okay. So I think it's so easy, like doing these. And that's what I'm afraid of, because like doing these, like, oh yeah, you have confidence that you can do it, and then the exam comes, you know. And I mean, there's like a couple of these. I can ask her for more, but I'm just thinking like maybe we should do some challenging ones after we do these. I mean, how many weeks is that? So we have this week, next week. So we have 3 weeks before the next exam.
Oh wow.
Yeah, the next exam I heard is on the 20th. Okay. And then I don't want to be complacent, like what we did with the other one. What I would like to do is what we did in the first one, you know?
Yeah, well, we only had like one meeting, so that's why.
So that's what I'm saying. Like we have 3 weeks, so it's impossible that you're gonna fail this one.
Yeah.
So maybe for this week, or maybe every week, would you mind meeting like in the weekend, but then longer? Like instead of 1 hour, maybe like
weekend.
Yeah, like a Saturday or Sunday.
Maybe on Sunday.
Sunday, yeah, Sunday's fine. But then like longer than 1 hour, maybe like 2 to 3 hours, just to compensate for like everything. Because I think it would be good that since you would already have like seen the topic, and then you guys have done like most of the work. And
yeah,
then
that would be okay.
okay. Yeah, just to plan out like how to review. So we have today and then I guess Sunday, 3 hours or 3 hours. And then
2.
I've
No.
actually done 3 hours of this too. Like okay, so 2 hours, we'll do that. Okay. And then maybe next week we'll do the same. I don't know how far she's gonna go though. Because she told me
Yeah.
she's gonna cover some of these other trig identities. Double angle, sum and difference identities. And those are the main ones. And then what's the other one? Half angle, yeah. Half angle, sum, difference identities, double angle, and the cofunction. Yeah, the cofunction one. All right, so okay, so for this one, tell me again how you do it. So you have cosine pi over 4. What is that one?
So that's square root of 2 over 2.
Okay, square root 2 over 2. Okay, and then times.
And then it would be square root of 3 over 2 for cosine 30.
3 over 2, right? Okay, plus.
Sorry, that was my cat. Square root of 2 over 2.
Square root of 3? Square root of 2 over 2 is the same thing. Okay.
Yeah. And then isn't the sign for that? Yeah, wouldn't that also be square root of 3 over 2?
Let me think.
Wait.
It's not though, because it's a 30-60 triangle, right? I think
Wait, is that pi over 6? I can't see what that
it's
says.
pi over 6. It's pi over 6. Yeah.
Okay. For sine, yeah, it's
1 over 2.
No, that's 1/2.
Yeah, 1 over 2. Yeah. Okay. And let's see. So yeah, you just do the math arithmetic.
So yeah, that'd be square root of 6 over 4.
And so that's just like. What was your final answer for this one? 2.
It's in my notebooks.
Okay.
It doesn't even out.
2. So that's square root over 6 over 4.
Yeah.
Plus square root of 2 over 4. Does it sound familiar?
Yes.
All right, I think that's it.
Yeah, and then you can put over a common denominator. So it's just like square root of 6 plus 2 over 4.
Let's just check if that's the one. So let me see. Let's put this
That
back
was
here.
that was what we got.
So that's cosine of 15 degrees. Okay. Is 0.966. And let's check what that is. 0.966. So square root of 6 plus square root of 2 over 4. Okay, that's correct. Yep, that's the one. Okay. And what about this one? Same thing. So
Yeah.
let's see. Let's go back here for this guy right here. So what's the 2, A and B, for these guys, if you remember?
I think so you have to times it to equal pi over 2. So I think it was
Oh, so there's like a multiple?
Yeah. So it like go down to pi over 4 or something. I remember.
Let me see. It's pi over 4 minus pi over 6. You could do that one, right? I think you could do that one.
Yeah.
So let's see. Pi over 4 minus pi over 6 after all like the fractions. So you have that. And then you just apply your identity again. So let's see, cosine of pi over 4 and then cosine of pi over 6 plus sine pi over 4. Do you ever like repeat like your homeworks like weekly, or do you just do it like once?
Once. I should probably do it more than once.
Yeah, no, I can tell. But like, yeah, you should definitely. That's like a suggestion because you just have to. It's one of those things. You have we have 3 weeks. I mean, I think the other ones was a little bit short. The other exam was 2 weeks, and like if you repeat it, like maybe like 5 times, because it just gets reinforced in your mind. And then the next week would be new things. Because then if you kind of like wait till the last minute, it's all just new to you. It's like not good. Okay. So cosine pi over 4. What is that?
Cosine of pi over 4?
Yeah.
That's square root of 2 over 2.
Okay, square root 2 over 2. I think this is kind of similar to the other one, huh?
Yeah.
What's the answer to this one? It's exactly the same. Because it is the same.
Yeah.
Yeah. Okay.
It looks kind of similar.
Yeah, sometimes the radian, this value, obviously, it's not your common one. Okay, so you do that, and then root 3 over 2 plus root 2 over 2, and then 1/2. Altogether, same thing, plus root 2 over 4. Awesome. All right, that's good, that's good. What about this guy?
Okay, then you have to plus for that one, I'm pretty sure.
Let me see. So tell me A and B. Let me check if it's short.
Maybe you could try 3 pi over 4 times 3, 9. You can do 9 and 8, right? 9 and 8. And then, so for the other value.
For this one, oh, it's over 12, not 2. Okay, 12. So what was it? What was it? What did you get? Like
Okay, so I know for a fact that one of them is 3 pi over 4.
3 pi over 4.
Mm-hmm.
Okay, and what?
I'm not sure what the other one would be. Would it be 2 pi over 3?
For this one, let me see.
Yeah, it would.
So sine, and it's just add. So you said 3 pi over 4 and 3 pi over 3. Oh, okay. 3, 4 plus 1. $17 over 12. And what was your final answer? Is it like over 2 root 2? And is that negative? Did you get negative number?
Let me go get my notebook. Wait.
Okay.
Actually, my notebook's in the car. I don't remember.
Okay. Let's see. Because that's what I'm getting. It's like negative 1 plus root 3 over 2 root 2. Well, let's see if we can do that step by step.
Yeah, because I don't think it was negative.
Negative 2 plus, yeah, that's what I'm getting in the sun.
What formula did you use? You used
the sine cosine minus cosine sine. So sine A minus B. You would do that one.
Sine A minus B, and then it's yeah.
And then so your A would be like 17 pi over 3 minus 17 pi over 4. Something like that.
No, you just use a regular value.
Which one did you guys get? Because you could do it another way. So like let me see if we got the same answer though. Let me see.
Okay, wait. So how we would do it is Sine A would be 3 pi over 4.
Okay.
And sine B would be
And is it plus or minus?
I think it's plus, isn't it?
Okay.
Because it's mine. Oh no, not. Oh yeah. For there, that's plus. Yeah.
Yeah. So, and then plus what? Like 1 or pi? 3 pi over 3. 3 pi over 3 is like pi, right?
No, I did 2 pi over 3.
2 pi over 3. Okay.
Yeah.
There's another way so this one, let's see if you actually get the same value. So 3 pi over 4. Okay, so that's 1.417, and then 17 divided by 12, let's see. Okay, so that's what you did. And let's check this other one. Yeah, okay, you could do it this way too. So like, this one would be the same as this guy. I mean, it's whatever you can stick, like, you know, so it's either plus or minus, or I think
we didn't actually like use, we never use 17 pi over 12 or anything.
Oh, you guys don't do this? Oh, but then like whatever this value inside has to equal this guy. It should be the same. Just to give you like two options. It should be the same. You know, like this right here should be the same as this, and then this should be the same. If you use plus or minus, it works either way, but you just have to know what formula you're using. But okay, you guys use this one, right? You said?
Yeah, we did that one.
Okay, let's see. I mean, it's always good to know like two ways, because then what if the other way doesn't work? So let's see. So applying that formula, let's say sine A plus B. So that's just sine of 3 pi over 4. And then it's a cosine. 2 pi over 3. And plus cosine of 3 pi over 4. All right, so what's this one? Sine of 3 pi over 4.
3 pi over 4, isn't that
3 pi over 4, that's the, yeah, which one is that one? I could look it up, but
is it square root of 3 over 2?
Square root of 3 over 2. Let me see. So it's this
or
one.
Wait, which one are we saying? For 3 pi over 4 or for 2 pi over 3?
3 pi over 4. So if you
no, that's square root of 2 over 2.
Square root of 2 over 2. Okay, good. Because like it's a 45 degree. Just X that. So root 2 over 2. And it's let me think. Opposite. Oh yeah, that should be fine. Okay. And cosine 2 pi over 3? This guy.
Isn't that for cosine 2 pi over 3?
Yeah.
Isn't that 1/2?
Let's see. So
or wait. Yeah. Right?
60, root 3 over 2, I think. No. Root 3 would be sine. Cosine would be 1. Yep, that's right. And then cosine of 3 pi over 4?
That's still square root of 2 over 2.
Okay. And then the sine, what about the sine? 2 pi over 3?
2 pi over 3 would be square root of 3 over 2.
Okay. So these values are starting to look similar. So let's see. So root 2 over 4 plus root 6 over 4. Okay. Did you get this?
Yes.
All right. Let's see if the other one actually gets you a similar answer. But like it seems like the math is a little involved because it's not like one of your regular ones. So let's see, y2 is minus 6. Why would it be negative? Okay, that doesn't matter. Okay, I guess this is good. The other one actually turned out to be negative. Okay, let's do number 4. So for this one, seems like they already did it for you. So you just have to evaluate, right?
Yeah.
Okay. So sine 80. I think you have to figure out, like, you have to split these guys, I believe. Yeah?
Yeah, so it'd be sine. Would you minus sine 80 and sine 20? Or no?
Let me think about this one. 80 minus 20, that'll be 60, right?
Mm-hmm.
And this formula is sine cosine minus cosine sine. So it's A minus B. Okay. And that's it. It's pretty much just the reverse, yeah? So sine of like, what is this, 2 pi over 3? Then you go, this is a 60 degrees, okay? Root 3, 1, and 2. So root 3 over 2, yeah? Is that what you got?
Yeah.
Okay. So not bad. So like, let's just review, step back and review. So 1 and 2 kind of similar. 3, I mean, you got the same answer, but the thing is, it's all the same procedures. And then number 4 is just the reverse of it, which, okay, that makes sense. So like, yeah, does that make sense? Like 1, 2, 3 are pretty much the same procedure, and then number 4 is just the reverse of what you did.
Yeah.
As long as you know like the sum and difference identity, I think you're good. I think we didn't touch on tan yet. The tan counterparts of this. We only did like sine and cosine. Okay. What about this guy? Okay, this is pretty much similar. So what's the reverse of this?
So it'd be, okay, so this is cosine AB minus sine AB, so that would be cosine plus, right? Cosine A plus cosine B.
Yeah, it's the first one. So pi over 12 plus.
I'm so sorry, I just dropped my phone.
Okay, and this one is 3 and then 3. So this is 4 pi over 12, right? Pi over 3. 4 pi over 12. So cosine of 30 degrees. Oh no, 60 degrees. So it's pretty much whatever you've done before. So it's just
1/2, right?
yeah, it's just this guy, the opposite of this guy. So it's 1 to root 3 adjacent. So it's 1/2. Yeah. They're pretty basic, right? But like the thing is, it seems like it's easy, but then how else can she give you guys this? You know, like this one seems easy. I'm wondering. Let me look at the other one. Let's take a look at the other one. Oh, okay. So you guys touched on tan, and you said this is something you guys are gonna do tomorrow.
Yeah.
Okay. I guess we can maybe kind of like preview it and not like, and then you tell me on Sunday how you doing it, and then we'll cover it and probably other ones as well. Let me try finding other challenging ones because these ones are quite easy, and I know that she won't bring something similar to this for sure. Maybe on top of this, it's gonna be a little extra. But like, just to talk about it. So for this one, 10, 7 pi over 12, what would you do?
I think you would do like the same thing you did for cosine and sine.
Yeah, very similar. It's just gonna be the 10 counterparts.
Yeah.
And then you find something that's easy, right? For A
Yeah.
and B. Okay. And what about number 2?
So, okay.
This is kind of, let me see. So it's the reverse, yeah? This is the reverse.
Wait, we haven't done like anything divided.
Okay, let me show you the actual formula. Let me go back, or actually put them side by side. It'll be easy to see. Let's see. Can you see this?
Oh, okay, yeah.
Okay, so like it's just the reverse. Yeah, I know, like you haven't seen it, but well, once you look at the formula, it's like right here. It's just the reverse, right? You take a look at this. Which one does it match on the right hand side? It looks like it's the first one.
Yeah.
So you just add these guys. So that's like what, 45?
Mm-hmm.
45, and then you know how to do that already. So okay. What about this guy?
So that looks like the second formula.
Perfect. Yep. So that's like 65 minus negative 85. So that's plus. So 0, 1, 150, something like that.
Yeah.
And I think you know how to do that as well, right? That's just the I think that's the third degree. Yeah, you know how to do that one. Okay. What about this one? Find exact value for each using sum or difference identities. Okay. Oh, okay. So given this guy, and this is this guy, find the exact value for each. Using sum or difference. So cosine of A is this guy. So I guess you just plug these guys in here I'm trying to find what cosine B or sine A is. Okay. In the exam, I saw you guys had something similar to this too in the quiz. She didn't really bring up something similar to this. It's more of like maybe like 1, 2, 3. No.
Yeah.
Okay. We'll cover like I'll try ask her. I mean, she's probably gonna give you guys more things. So you said that you guys already got these ones, right? I don't know how many times your teacher is gonna give you guys like worksheets every week. So I'm gonna try ask her again at the end of the week. So like I think it'll be better because this one's kind of like something you guys already have.
Yeah, I mean we have homework.
You guys have homework? Okay. She didn't
Yeah,
give me
I could send you it's on like a textbook, so she like doesn't really send it to anyone. But I can send you. My friend took a photo of it, so I can.
You guys have a PDF of the textbook by chance? Or is it like accessible? Have you found one like a resource?
It's like an actual like textbook. It's kind of hard to navigate, not gonna lie. So I'm not really sure how to do it. So I just take pictures of the.
Okay, that's fine.
But I could ask her how to do it.
Yeah, like whatever works. Maybe just take a picture first, and then like, just send those to me. And then what I want to do is, since you do have a textbook, like that's why it'd be better if I have it, because I want to actually find or give you like problems that are similar to what you will see, But these ones are still simple. There's ones that I can give you on Sunday. So okay, so for Sunday, we'll cover kind of like similar sum difference identities, and then like maybe like kind of like what you guys did in the exam, simplifying expressions. I think like that's like one of the biggest things in proving like identity is like equal something. So I'll do that, but then actually applying some difference identities. And did you guys
Okay.
cover double angles yet? And then the other ones?
No.
Okay, cool. Maybe we'll put that off for like next week. I think one by one.
Yeah, once we like learn it in class.
Yeah, that's why I like it if we do it at the end of the week, because so then you can like update me on what you guys did, and then your teacher can send me like everything already in one go.
Yeah.
Okay. Yeah. So yeah, don't worry so much about your grade. Like you did, it balances out with your the one that you got 95 in. So for this next one, since we have more time, let's really drive this all the way to the end, where at least maybe this week we'll do 2, and then 3 next week, and then maybe like 3 the following week once we get close to the exam.
Let's see how 2 goes. Let's see how 2 hours goes.
But let me know. Like what the one thing I want to know is like the questions, because like last week it seems like you weren't able to ask the questions, I know. But maybe like looking at these problems, it seems easy now, but maybe there's something that you want to practice more in. But you're not struggling right now with these problems, though, right? The ones that we covered.
No, I actually kind of like them.
Okay, they're not that bad, yeah.
Yeah, I like when there's like clear formulas. It's like so much easier.
But the thing is, where it gets hard is when you're finally applying it in like simplifying expressions. Those are usually the harder ones. Simplifying expressions. Okay. All right. Well, I'll schedule one for Sunday, and we'll go from there.
Okay.
Cool. Have a good one.
You too.
All right.